Everyone, my name is Matt Berninger. I'm just gonna hold this, I guess. And yeah, this is, so this is a presentation on ARNIE, which is a backronym. I was in the government, so I can't help myself. I love backronyms. And with this talk, I'm really hoping to open a discussion. So I would really like any and all of you to convince me to not do this, because there's just so much regex involved and it's been really painful. So let's get into it. Expect puns and bad jokes. Next slide, please. Some stats about me. I'm a senior manager on the detection response team at Expel. We're a burgeoning MDR provider in the managed defense space. Previously, I was at Mandiant, FireEye, all those iterations. Have a lot of friends here, so it's good seeing y'all. My background was in incident response and then sort of going into the managed defense space and then into data science. And now I'm kind of back in the managed defense space. So I just keep riding this roller coaster. I have more than 0 children, which means I'm wildly unprepared for this presentation because I'm very tired. And a fun fact, I watched way too many. I understand this now. When I was a kid, like an early age, not the right age to be watching like gory action movies. My dad we'd watch like Arnold Schwarzenegger movies a lot. And now I understand that because I've watched Encanto like 3,000 times and I don't want to do that anymore. So I get it. But I watched a lot of those. And so that's probably subconsciously why I named it ARNIE. And some acknowledgements to my teammates at Expel, Dan Whalen, who wrote actually the package that I'll talk about internally, and Evan Reichert, who's on my team, who's helping me work towards something a little bit more open source and shareable. So next slide. So let me know if you've said this. I know I've heard this at these past CAMLISs. I've said this. A lot of problems in cybersecurity sometimes feel like an NLP problem. And when I first encountered that and I was sort of learning about NLP, I was like, ooh, this reminds me of code, kind of. Like, I think I'm a thought leader. And it's funny because as I've gone down that road, I've presented here before, and the first presentation was about a model that went to prod. The second was about a model that got sort of stuck in research. And now I'm not even talking about a model. I'm talking about why I can't make models. So I think the next presentation will be like how to turn on my computer. It's just getting worse. And so I looked up some of this, and like these are all like purple links on my browser, right? Hey, I'm trying to file path encode. I've got like a file path. I need to normalize it. It's like system32, but then sometimes syswow64, and like the program data, it's like x86 sometimes, but sometimes it's not there. And so let me know if you've written regex to solve those problems. It's really frustrating. I know Phil has. Phil, I know you encountered this problem with file paths. You actually wrote a really good function for that. Defining a distance measure between 2 IP addresses, right? How close is a 10 dot and an 11 dot? Pretty close to a computer, not very close to the internet, right? So there's these problems and these sort of like hidden rules that we run into. And if you Google these, you'll find a lot of stuff on like Stack Exchange and Math Exchange, people asking these questions. And these are all like unanswered, by the way. People have asked them like unsatisfactory answers. PowerShell command line arguments parser, that's a fun one. A lot of regex there. So a lot of like, I'll get into some of the examples here, but if this sounds familiar, this is a dynamic I've encountered many times that like, ooh, I can just pass this into a sentence encoder, but then oops, it doesn't actually work that way because white space delimiters don't really work in cybersecurity. A lot of problems fit this sort of shape. Threat grouping, the Intel threat grouping thing I presented a couple of years ago. Command line classification is like a pet project of mine. I just love it. And code similarity, there's been a lot of talk about that here. And really some interesting approaches have been presented that I'm going to think on. So it's been really good being here already. Next slide, please. So we're going to move on. Oh, I have the thing. Oh, I didn't this whole time. There's a power play. Oh, look at that. Amazing. That's depressing. I'm embarrassed. So I thought about like, if you do NLP, like who here's used NLTK? Like just quick, okay, yeah, we've all used it, right? And like, what's the benefit of NLTK? That like, you don't have to do the tokenization part, right? Like the first step of an NLP project is like, cool, you understand English, NLTK, and other languages. Make it into a list of tokens for me, please. Great, now I'll go do some really advanced data science. But like that step is, in my opinion, one of the hardest steps when you're interacting with like complex artifact spaces, alerts in cybersecurity. There's been a lot of talk about like portable executables and files, but when you're talking about stuff like logon events or cloud API calls or PowerShell execution or process events, stuff like that, those artifacts don't lend themselves to some of the complex methods that we've talked about here with malware. So like simply doing this to like a PowerShell string is hard. It's like frustrating. You write a lot of regex. I have. So NLTK is really helpful because it allows you to take that first step towards building your project, and it unpacks a lot of that. And additionally, I don't know, I've got it. I looked at like, are there other examples of other domain spaces where there are like specific open source packages that people can use to sort of get off the ground? Hey, I want to write my own new Shazam algorithm to process audio data. You can do that. Labrosa. I don't know if that's the best one, but my Google search indicated. BioPython. I mean, a lot of times you run into like biology has solved a lot of our problems in data science already, but like there's a freely available tools for biological computation written in Python. Cool. That sounds really helpful. If I wanted to do a biology project, I'd probably look into that. PyBaseball, I gotta, go Phils. I've got to make a plug. It's always baseball playoff season here. And yeah, if you're interested in like baseball statistics, you can get started with PyBaseball and get you off the ground in that research and allows you to understand how to parse baseball stats off of whatever database you're using. OpenCV for, what's OpenCV? I'm blanking. Images, thank you. Yes, of course. For images, yeah, like you don't have to write your own image encoding library. You can just use the stuff there. So again, it's sort of this tool set that we can use. So thinking about that for cybersecurity. And in addition to just being convenient, what I find is that it has a huge impact on the project, right? I've written a number of models where I've spent a lot of time down here just parsing and labeling this stuff. And like we all talk about, the modeling is like the last 5%, right? But as a data scientist, you're like doing model selection, hyperparameter tuning, like, yeah, that's just kind of icing on the cake by the time you get up there. But if you figure out, oh, I've got a new way to parse that and actually pull those tokens out in a meaningful way, where I'm actually pulling out the PowerShell arguments or I'm breaking out the base64 decoded stuff, like that will have a huge impact on the efficacy of your model, as opposed to like, hey, I found a new model structure or, a new network architecture that's going to do this. Like, this is where the juice is at, I found in my experience. And additionally, it's really hard. Like hyperparameter tuning and model selection is fun. As a data scientist, like that's cool. You make cool graphs. Like, oh, listen to my computer. It's like training right now. It's so cool, But like labeling and parsing and just like reading regex pal till your eyes bleed is not fun, but it's important because that has such a huge impact on the output and interpretability of your model. And so that's what I also find that like you tend to be doing a lot of stuff with operations and product down at this level. And then the data science team kind of takes that parsed data and runs with it. But a lot of stuff sort of gets dropped here. And so that's something I'm trying to help with this discussion. So the problem with cybersecurity, this is the problem with cybersecurity. Just know this is it. So like, I don't want to go too far down this road, but puppy running in the field has semantic meaning to your brain. You can think about what that means, and now you'll forever remember this picture. It's very cute. Like we know what that means, but like this is a base64 encoded command. base64 encoded command, and like as an analyst, I look at that and immediately like, oh, that's base64, like open CyberChef immediately and get into it. But like translating that meaning into some sort of vector is the trick, right? Is like this is the problem. Is that NLTK can help us sort of parse that and feed it into the model, where it's like we have to do a lot of work to get from the cybersecurity artifact to like words that we can pass in. Okay, so like just do a neural net, man. Like why just and there was actually a really good presentation just now about LSTMs, and just pass it in and it'll just learn the rules of PowerShell and it'll learn the rules of JavaScript. But one, I've tried that, and I'm not the best neural net trainer by any means. It might be the worst. But what tends to happen is the data sets are really small and they're really sparse. So you might have all PowerShell and a little bit of JavaScript, or all JavaScript and a little bit of PowerShell. And I frankly haven't really trusted some of the results I've gotten from those approaches. Feeding that stuff into an LSTM and expecting the LSTM to understand the level of depth and complexity in something like a PowerShell command doesn't always hold up. And in fact, sometimes all the information in that artifact isn't even readily apparent. We just, when we're talking about domains just now, it was like, yeah, you can actually have an LSTM learn this domain, but it can't learn about the domain age of that domain. That information's not there, right? And so there's some sort of like enrichment problems that come up with that. So it's not to say we can't do this. I eagerly await somebody to show me an LSTM trained on PowerShell commands. That would be awesome. Please present that. But I've tried this a lot. We actually had a lot of honeypot data a while back, and that was the biggest data set of command strings I'd ever seen. And it just wasn't really operating. And additionally, you have to pass those results back to an analyst to make a decision in many cases. And the interpretability layer just gets really tricky with something like a neural net learning off of character encodings of artifacts. So yes, we should, but I just have failed thus far. So going back to like this NLTK for cyber idea, the idea to begin with is just a basic set of tools, like a regex artifact identification. If you've ever Googled for how to do a regex for IP addresses, raise your hand. We've all done it. Yep, it's a purple link for me. Now, if you've done internal IP addresses, wouldn't it be nice to just have that like always? You don't have to go look for it. It's just there. Just do that, just as a command. Maybe you have it as a function. If you do, please publish it to GitHub. But I keep going back to the same Stack Overflow post for that. It's like starting there, starting with domain parsing, starting with Windows path parsing, Linux path parsing, that type of normalization, just basic tools to normalize some of these artifacts would be really helpful. And then basic prevalence. We talk a lot about prevalence in the MDR space. And there's actually a lot more there than I think is often discussed. Many times we're like, how prevalent is this in general? How prevalent is this across the customer base? When you look at something like logon data, I have an example. The prevalence matters quite a lot. In fact, the username doesn't really have any meaning aside from as a key for prevalence. And so simple calculation functions for calculating that prevalence and encoding that username or API key as a prevalence vector would be really helpful, and not having to write that code every time. And then getting a little bit more complex. Also, like this toolbox picture was awesome. It came up immediately, and like this dude's dead serious. So something that is strong enough for a grown man to stand inside of the toolbox. And there's like a bunch of those, like the whole product suite. He's always standing in the toolbox. It's great. I was just like, yeah, it's literally the first image I put in the presentation. This idea of like named entities, the Majestic Million, great example, right? Like those are named to some, follow me down this road. They're named entities in the domain space, right? These are like important things. Enrichment. Hey, I'd like to be able to just quickly be able to pass an IP address, recognize that this is an IP address, and go out to VT or IP info or whatever and pull that stuff down and append it to my record so I can vectorize that information as well. That would have helped with the domain registration details in the previous presentation. Relationships between artifacts. There's been a lot of talk about graphs, graph embeddings of relationships between artifacts. Hey, this PowerShell command decodes and includes this domain, which includes this file, which when downloaded, reaches out to this domain, et cetera. The ability to link those things together and generate those artifacts would be really helpful. And decoding scripts. Who here has used CyberChef? Yeah, so like CyberChef Magic is awesome. It's a script. Like you basically can download it and like execute it as a script. I thought, hey, wouldn't it be cool to have a function to be like, just download my CyberChef recipe and run it as part of my feature extraction function? That would be cool. If anyone wants to do that, hit me up. All right, so we have an artifact. There's a couple different areas for adding or pulling some of this stuff out. So just to organize this, you have this idea of the sort of low-level parsing and normalization. This is like, is there a base64 encoded block in this PowerShell command? Normalization, hey, putting app data, normalizing the username, stuff like that. syswow64 and system32 being functionally the same, and depending on your Windows version, those sorts of things. That isn't sort of populated by forensic knowledge. So that's forensic knowledge drives that stuff. You have to know that different NT systems in Windows will have different path names for different files, or for the same file rather. Enrichment, again, knowing that you can go out to VT or IP info for IP stuff, domain tools for domains, VT for lots of like hash enrichment services. There's lots, it's actually increasingly more external services for enrichment. So those populate the enrichment sort of area, and then prevalence is the population calculations. And the problem with prevalence is that these first two, you can do entirely within the context of the artifact. So if you have a processed execution, you can normalize it just without knowing any of the other process executions in the environment. If you have a file, you can enrich on that hash with an external source without knowing the rest of the population. If you've run into this problem with prevalence, if you're like, hey, I have a username logon, I want to find out how prevalent that is, you have to run that function across the entire data set. And so that function, that feature extraction function becomes very expensive. So there's considerations to be had there that aren't here. So like, this is like a row-wise operation. That's like a population operation that occurs across the entire data set. You can't figure out what the prevalence of a logon is without looking at all the other logons in the environment. So next slide, please. So this is from a blog a couple years ago on PDB paths. This is just examples to sort of color in what I've said already around normalization. So here you have the user path, put username there, documents, and just, lowercasing it. And then something as simple as recognizing that these MKZYU91952 is just random. Like that's actually not important. I don't want to actually record that string. I just want to record that that string was random. And I might want to record that that string was random and the same as the PDB file. So there's a lot more signal here than just the string itself, right? There's the normalization, removing the user name so that I can match this. If this were to go into, Jane Doe's documents folder 2, you would want it to look the same. But also removing long-tail distributional problems like having the one-hot encode specific random character sets. So this is just an example of sort of admiring the problem here, how complex it can get on file paths. Wait, did I go past? Now, here we go. Enrichment. Yeah, I did go past it. So enrichment, again, with an IP address, it's not a string. It's a key to lots of other information. So wouldn't it be nice to have a package that can just click a button, run a function, and grab all this stuff? This is all from RobTex, I'm pretty sure, in IP info. This is actually the camlis.org IP, by the way. That's figured that was apropos. But like this sort of information, you want to pull this and append it to the record, append it so that now you can turn this into your vector. That type of movement would be really helpful to have a library to help with. And to be clear, there are libraries that can help you with this, but they're not as generalizable to just plug in your enrichment source and go from there. It's specific to the API you're talking to. Logons, I talked about this already. There's nothing forensically interesting about usernames, like it's J Smith, right? That like you don't look at that and go, ooh, J Smith, that's definitely bad. But you're like, I wonder how often that person logs on from this location in Illinois at 2 a.m, right? So that's all prevalence. And we see a lot more just from an operations perspective, an increasing number of compromises are happening around identity. Cloud, identity, that's where the action's moving, or at least expanding to. And as an analyst, it's really frustrating because if you hand me a process execution tree, I can do my cybersecurity job and parse it and cyber chef it, look at stuff and pivot and do all the cool cyber things. If you say, hey, Matt logged on from New Jersey today, is that bad? It's like, I don't know. What, does he live there? Like, and so you're not looking at some of the forensic data sources that you're used to. So it's all contextual. One of the dynamics that I've encountered is that sources, meaning IP addresses and like usernames, something about the source, who done it, that prevalence tends to be most important within the context. These blocks are specific environments within the context of the environment. For that company, for that domain, how often does that person log on from that location? When it comes to actions, what we have found in our research is that activity, particularly in the cloud domain, tends to cut across environments. How often does that action follow that action? How often do those actions get grouped together? That type of activity tends to be consistent, have distributions that speak across environments and are not necessarily specific to a given environment. And this is why prevalence means a lot of different things. If you just say, give me the prevalence, well, that depends. What's your numerator? What's your denominator? How many combinations are you anding together to find that prevalence? Is it user name and IP and user agent for that time frame or something else? And so being able to quickly swap things in out of that equation is something that I found really helpful when talking about prevalence. HTTP request is just log4j, just to trigger some people who dealt with that. It still triggers me. But yeah, this is actually off of a Checkpoint blog. They published this. So yeah, I mean, just parse this, right? Like feed that into NLTK, see what you get, right? So this is just illustrating how this problem can get really gnarly really fast. And then not only that, but you have a recursive issue. So even if that's all you've got, okay, go for it. Okay, I'll decode the base64 encoded command. You actually have a recursion issue where now you've got this PowerShell argument with a base64 encoded command with this reg server squibbly do syntax. Oh, and by the way, I have to pull off that IP and then enrich that. So you've got layers and layers and layers. And the depth of those layers actually has forensic value, right? Like how far down did I have to go to decode that thing? Anyone who's doing malware reverse engineering understands this. So what you can have is actually a command that you parse, comes into tokens. Two of those tokens, let's say, are encoded. You decode them, you parse them, and maybe that third one, you decode that further. Maybe it's gzip, and oftentimes you see this in PowerShell. It'll be gzip encrypted, and then you decode and parse that. And so you have a couple options here. You can take all these tokens and append them. You can cut off at one level, or you can keep going. And so how you turn this into a vector is a real consideration into the efficacy of your model. And then graphs, of course, just, got to have a network graph. It would be cool, and this is sort of like phase 2, phase 3, to have a graph encoding, graph embedding portion of this package that is like, okay, you can actually refer or reference these things to one another, and then graph encode that into a vector accordingly. So that's sort of future work once we get the regex sorted out. So we have this problem at Expel, and lots of different places. We have alerts that come from all sorts of different sources. How are we on time? Sorry. Cool. We have alerts that come from all these different sources, integrated technologies, and they have all these different structures. And sometimes it's MD5, sometimes it's MD5_hash, sometimes it's SHA-1, et cetera. So like, how do we normalize that and make sense of it? And so we actually have an internal package that we use, that we are using in one of our models. And as we were using it, we thought, well, gosh, this actually solves a problem that we've encountered in a lot of different places. Wouldn't it be cool to sort of build something more community driven? So a couple of the guiding principles of what we have is it's modular. It has to be able to extend to new artifacts as our industry continues to expand and pull new data sources. The cyber industry is like really exploding in a number of different like security signals that exist now. It's not just file, network, execution. It's like all this stuff, particularly in the cloud. And so we see this increasing diversity of artifacts. And so being able to service that is important. Extensible, incorporate new enrichment sources, new data structures, new languages, and explicit. One of the problems is like, if you write these functions, and I have, when you go back and you're like, you know what, I think we're parsing out the HTTP request wrong. You have to dive so deep into that function to find the thing that's doing the thing. And so trying to build that transparency layer is a challenge. But being able to parse, pass regex filters in, pass enrichment sources in, and be able to, unpack that quickly is a priority as well. So how we use it, this is a blog we published a couple weeks ago, Alert Similarity. And basically, when we have a detection pipeline, we have alerts that come in, and basically the normalization layers, ARNIE, which allows us to translate, and my images got messed up, translate that alert into a normalized object that we can then vectorize. In this case, we're using, I think, min-hash. But it allows us to have faith in that normalization and allows us to unpack it on the way back, right? So, hey, analyst, I just showed you these 3 super similar things. And I'm not going to show you an array of floats to tell you why. I'm going to show you the actual artifacts. And being able to unpack that is so important. And so making sure we have this interpretation layer between alert and vector is kind of where the ARNIE idea came up. Future concept architecture for something more community driven, which I want some feedback on as soon as I'm done talking. We have a document. So sort of thinking of an alert as a document. And an ARNIE document, once passed through this hypothetical package, would have enrichment details, normalized artifacts, and then like, depending on how you want it to vectorize it, vectors that are associated with it. If you're an engineer, you probably see that this is like storage and computationally impossible, but as a data science nerd, I think it's great. Just append everything to it. I just wanted to look it up once. And then off of that, you can sort of hit these parsing, enriching, normalizing, and encoding functions to add those things to that record so that this record just grows and you can associate those things accordingly. And then this is kind of the dream. I haven't fully thought through this yet, but wouldn't it be cool with that normalization and encoding layer to be able to actually share alert data sets? And I mean real alerts, not DARPA, KDD, CUP, 99 alert data sets, not honeypots, not CTFs, but like actual alert data sets. The problem right now is that those things are sensitive, and rightfully so. But if you're able to normalize out usernames and actually normalize out the things that make them sensitive, or even at the very least be able to share the vector data sets and with some level of trust, say, hey, this is actually the vectors that I generated, and have some level of security around that, that would unlock a lot of research in other non-malware domains for cybersecurity that we've been thus far unable to really do as a community. We do a lot of malware research because we have malware data sets. We don't do a lot of process execution research as a community because we don't have those data sets. We don't have customer data sets for good reason. But if we could create a layer in between that sensitive data and actual vectors we could work on, that would be really cool.